बिस्मिल्लाहिर्रहमानिर्रहीम। अस्सलामु अलैकुम वरहमतुल्लाहि वबरकातुहू। मेरा नाम अदनान मसूद है और आज मैं आपसे मसनूई ज़हानत की इंडस्ट्री में यह हकीकी वर्ल्ड रियल वर्ल्ड इस्तेमाल के बारे में कुछ मारूज़ात पेश करूँगा जो उम्मीद है कि आप तालिब इल्मों के लिए मुफीद साबित होंगे। मेरा ये मुख्तसर सा लेक्चर ज़ीशान उस्मानी के अन्नाफ़े पर मसनूई ज़हानत के कोर्स के लिए बनाया गया है। मसनूई ज़हानत की इतलाक़ या एप्लीकेशन के बारे में आप जानते ही होंगे कि ज़िंदगी के मुख्तलिफ़ शोबाजात में तकरीबन हर शोबे में और हर इंडस्ट्री में इसका किसी न किसी तरीके से अब अमल दखल शामिल हो चुका है। अल्हम्दुलिल्लाह इस सिलसिले में मैं खासा खुदशनसीब वाक़ई हुआ हूँ क्योंकि AI चीफ़ आर्किटेक्ट के तौर पर मुझे मुख्तलिफ़ शोबाजात मसलन सेहत आमा या हेल्थ केयर, मालियाती टेक्नोलॉजी या फिनटेक और रिटेल या खुर्दा फरोशी में मुख्तलिफ़ अक़साम के प्रोजेक्ट पर काम करने का मौका मिला। अपना मुख्तसर तारुफ़ कराता चलूँ, मेरा PhD मशीन लर्निंग या बेजियन इन्फ्रेंस में है और मैं माइक्रोसॉफ्ट का मोस्ट वैल्यूबल प्रोफेशनल या MVP और रीजनल डायरेक्टर हूँ। इसके अलावा मैं इससे पहले विजिटिंग स्कॉलर के तौर पर डॉक्टर क्रिस्टोफर मैनिंग की लैब में स्टैनफोर्ड यूनिवर्सिटी के अंदर काम कर चुका हूँ, जिसके अंदर मुझे वर्ल्ड क्लास रिसर्चर्स के साथ काम करने का मौका मिला। इससे कबल प्रोफेशनली मैं मालियाती टेक्नोलॉजी के साथ या फिनटेक के शोबे में एक तवील अरसे तक काम कर चुका हूँ, जहाँ मुझे मोहम्मद फैसल जो अल नाफ़े के रूह रवा हैं उनके साथ भी काम करने का मौका मिला। इस मुख्तसर सा लेक्चर में मैं आपको कुछ ख़ास इतलाक़ियात या प्रोजेक्ट्स के बारे में बताऊँगा जिस पर मैं और मेरी टीम ने काम किया, ताकि आपको इस बात का अंदाज़ा हो कि मसनूई ज़हानत किस तरह हकीकी तौर पर इंडस्ट्री में इस्तेमाल होती है। इसमें नेचुरल लैंग्वेज प्रोसेसिंग, मशीन लर्निंग ऑपरेशंस और अखलाक़ी मसनूई ज़हानत की कुछ मिसालें शामिल करूँगा। चूँकि मसनूई ज़हानत में ज़्यादातर इस्तिलाहात अंग्रेज़ी ज़बान में होती हैं और मैं अपनी बात तकनीकी पैराए में अंग्रेज़ी ज़बान में ही बेहतर तरीके से समझा सकता हूँ, लिहाजा मेरे लेक्चर का बाकी हिस्सा अंग्रेज़ी ज़बान में होगा। बहुत शुक्रिया। From driverless cars to virtual doctors, artificial intelligence is transforming the way we live, work, travel, and do business in the 21st century. PwC estimates that AI would add as much as $15 trillion to the global economy by 2030. So today I'm going to walk you through these AI industry use cases. You can see there are a lot of them. The top AI use cases includes customer experiences, predictive analytics, supply chain, real-time operations management, and it applies to all different industries. So from manufacturing, retail, healthcare and life sciences, travel and hospitality, financial services, energy feedstock. So all of these areas have some of these specific use cases as part of this AI and machine learning spectrum. So here some of the case studies which I'm going to talk about today. I just want to make sure that you follow the idea that these are not just the use cases. These are the specific case studies which I have worked on, and those are the ones I'm going to talk about. But in general, they're in healthcare or in pharmaceutical research. You take retail, marketing, finance, intelligent process automation. I mean, take any vertical around this and you will see any sector has a fast AI investment growth happening right now. So it's really important for us to get up to speed in that area as a student and be able to practice that. So the three key case studies I'm going to discuss includes extracting and understanding the healthcare explanation of coverage documents for a medical insurance provider. So the idea here is that there are tons of different PDF documents. How do you extract and get information out of those? So that's the first case study I'm going to talk about. I did this for a large medical insurance provider based out here in the US. The second is for a financial institution. So then the second case study, I'll talk about how did I implement a solution along with my team where you understand bias in the model for a financial institution. So bias in the model is a big problem. So you cannot have gender bias, age bias, racial bias, any kind of bias in the model. So when artificial intelligence makes a model, when you make a machine learning model, it may end up having some sort of bias. So that bias is not necessarily good for overall, like from regulatory purposes or from legal purposes, because if you deny somebody loan based on their gender, their marital status, their sexual orientation, their any of the key attributes which we are called protected attributes, then that's essentially a lawsuit. And not only that, there's unethical biases associated with that. So having said that, this is a big concerning area for financial institutions. So this solution actually helps you fix that problem. The third and last solution I'm going to talk about is end-to-end machine learning operations implementation for supply chain. And this was done in a telecom sector. So supply chain is a big part of any retail operation or telecom or virtually anybody who sells anything. They deal with some sort of supply chain. So, and how do you build an experiment around an end-to-end machine learning operations lifecycle where you can test your machine learning do champion challenger testing? So for example, if you want to experiment with different type of distribution channels, different type of devices, different type of interfaces, how would you test it around building and deploying an end-to-end machine learning lifecycle? So that is the third problem statement I'll briefly go over. So these are the three key areas we will go over today. Okay, so let's look at the first problem statement. The case study we are working on has a lot of healthcare documents, as you can see on the screen over here. So you have physical therapy, occupational therapy, chiropractic care, some of those documents associated here, and those are PDFs. So what you have to do is to build a pipeline where you ingest these PDF files out and then process and make a model out of it, and then do named entity recognition and understand all this. So it sounds relatively hard, and it doesn't sound like a machine learning problem, because when you think about machine learning, you're thinking about, oh, I have to make a model. But that's not always true. When you are building an AI machine learning project, you have to do more than just build the model. You have to do a lot more things. You have to do ingestion of the data, processing of the data, cleaning up of the data, then have to make sure that the data is actually useful to be used as a part of the problem statement. You have to also split it in testing and training parts, and those will actually help you. That split helps you train the data more effectively, your model, and you have to do the split in a variety of different ways, which you will learn as part of this course you are taking. So just wanted to let you know that the model building is one part of this equation, and it's a much bigger problem. So on the left hand side, you can see the natural language processing part from a legal perspective, from a healthcare perspective. On the right hand side, you can see some of the things you can do with the legal. All right, so here you can see this is a reading comprehension example where I'm using BiDAF. It's one of the algorithms around natural language processing, which allows you to be able to do text comprehension. All right, so it's a very, it used to be state of the art, no longer state of the art, but there is a leaderboard you can look at, a squad where you can find out what are the state of the art algorithms around reading comprehension. Reading comprehension in simple words mean how can you take a paragraph or any kind of text and then try to understand things out of it, right? So here in this case, the paragraph is, The Matrix is a 1999 science fiction film written and directed by blah, 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 and then it talks about all the details of that movie. And then I can, it's just this paragraph, that's all there is, right? So I can ask, who's the protagonist in The Matrix? And it tells me the Keanu Reeves. And you can see here, it says starring, not protagonist, right? But protagonist means the same thing as hero, or a person who is starring in the movie, and it's able to figure that out, right? So I can also say, who is the hero in the Matrix? And let's see if run this. It still finds out Keanu Reeves, but in this document, it doesn't say anything about a hero. How does it know that? So the way it knows it is by applying these deep learning models, which find out that the word hero and the word protagonist and the word star, these are all correlated concepts. So it can do this substitution by using this technique called attention network. And that's exactly what we are able to do that for those large PDF documents I just talked about, and then look through those PDF documents and figure out what is each of the things mean. So what is a real world application of these things? So think about those documents for healthcare. How can you use those healthcare documents to answer questions? So if somebody calls a call center and says, I'm having back pain. If I go see a doctor, how much do I have to pay? Somebody has to go and look through a large document to find that information. Instead of doing that, if we have a system like this available, it can actually go through that tons of PDF files, figure out what cost associated is required, and then it can answer that question, right? So I can show you a simple example over here. I can say, when was Matrix movie made? All right, so I can ask this, and then it's telling you 1999. Now you see, this is all unsupervised. I did not train the algorithm to do any of this work. It's all unsupervised. It's not a model, not using anything in this case where it was pre-programmed. This is the paragraph. So just to demonstrate that point and further and drive this home, I'm going to select, instead of that, I'll just go ahead and use a new paragraph here. This is about COVID-19. It talks about what is COVID-19, how do people get infected, etc., right? I accidentally ran this, so it's going to take a little bit of time before it gets done. Okay. Maybe I should just refresh the page. That might be faster. All right, so I'm going to go ahead and paste this text over here. All right, so here's the paragraph. So it has a lot of different items in the text here. For example, what to do about COVID-19, etc. So here I can ask a question, a simple question about COVID-19. So there's a question like, what when I'm sick with COVID-19? How do I protect myself, etc. So let's think of a question. What should I do if I'm sick with COVID-19? If I run this, it's going to find it. And here it's find out. If you think you have been exposed to COVID-19, develop a fever and symptoms of respiratory illness, and then it tries to figure out what are the different aspects you can do. Like, say, just call your healthcare provider immediately, right? So this is how it's able to discover what are the associated items you can, or actions you can take. So it finds the attention and finds the item associated with what it is, right? Wash your hands often with soap and water for at least 20 seconds. So I can ask, how long should I wash my hands? So I run this and it's going to say 20 seconds. And so now all of this, I just copied and pasted the data set and it's able to figure it out on its own. So this case study shows you how powerful these algorithms of reading comprehension are. I'm using LN-NLP library. There's another one called Hugging Face. You can also use that. Hugging Face it's now they're called transformers, and the company is called Transformers, and they use this thing called transformer networks, and those are used for applying the end-to-end understanding of the network. So they get trained on large corpuses of data, including Wikipedia, including internet corpuses from a variety of different places. So there is also Common Crawl Dump, which uses, it's also a huge crawl of the entire internet. It uses to train huge models. All right, so this specific use case was around natural language processing for healthcare and how you can use that to understand those PDF documents. And this is a very valid use case in any industry. You can look at legal, you can look at finance, you can look at any places which deal with large documents. It's a very helpful use case. Okay. The second use case we are going to talk about, like I said earlier, was around the understanding the bias in the model for financial institutions to make the credit decisions. Okay. So understanding the bias is an important thing. Why is it important? I'll just quickly show you a couple of slides around this. All right. So let me share my screen to show you the slides. Here you can see. I'll skip this. All right. So why do we need ethical AI? So ethical AI is essentially, it's a huge concept. To build trust, to debug, to regulate, these are all different aspects of ethical AI. It's a huge topic to cover in this short amount of time. I just want to walk you through a use case which I worked on specifically around ethical AI or around this, is that racial bias or native country bias or any kind of these biases are not good to be in the data. So if you look at any data set, and you can see the feature importance plot here, it shows that this specific model has a huge bias against marital status. So the people who are getting loans are the ones who have a marital status of being married. The same thing can apply to some people who are getting loans or who are getting approved, have a higher level of education or have more income. And those are okay factors, right? If somebody has a higher income or somebody has a stable job or somebody has a good credit score, then it's okay for them to be approved for the loan because they will return the loan most probably, right? There's a model associated with that. But if you are going to correlate that model with race or gender or any of these other biases, societal biases, then they don't have impact directly on this, right? And we don't want to tie any of those societal biases with our model, because it's not only regulatory wrong, it's from a governance perspective or from a legal perspective, but also it is unethical to do that. So here in this case, for example, marital status or age, for example, if somebody is older, giving them loan versus somebody is younger, there's a bias around that. So the approach for this financial institution was, how can I detect bias in my models and how can I eliminate the bias? So that is the use case. So again, repeating the problem statement or the case study we worked on is, how can you detect bias in a model and then eliminate the bias? Okay. So I can't, of course, show you the actual implementation of the model. These things are proprietary. But what I can show you is how you can do this today. All right. So I'm going to quickly pull up my Jupyter notebook over here. So here is the tutorial for credit scoring, and you can get it easily from AIF 360. AIF is AI 360 by IBM. They made these notebooks available, and I'll give you the link for these notebooks as well. And so I'll skip some of the things. It shows different steps like import statements and how do you set bias detection options. Colab, by the way, is a great tool. It allows you to be able to run Jupyter notebooks right on Google for free, and it comes with these cats, so that's really fun. All right, so I'm going to go ahead and run, like for example here, I'll run the pip install for the AIF toolkit, which allows you to mitigate the bias. Okay, so it does the pip installation for that. All right. Okay. Then now I'm going to do all the import statements. I import the German credit dataset. German credit dataset is a test dataset I'm using here to showcase how the bias reduction works. In this case, you can see how we'll import the German credit dataset and also look at the biases in there. So there's a bias around age in there, and I'll show you how we eliminate that bias. So these are just typical import statement, nothing fancy here. All right. So here now it's happening is it's actually imports a German data set. All right. And then also defines that there's a protected attribute, which is called age. All right. So it looks for the protected attribute being there. And there are different privilege classes. So privilege class here is greater than or equal to 25. What does that mean? That means that it seems like in the data set, by looking at the data set, and you can parse it out and look at it, is that if somebody is over 25, there's a huge chance that they will get the loan. If somebody is under 25, they don't get the loans, right? So we want to eliminate that bias from here, all right? So the privileged group age is 1, unprivileged group age is 0. All right, so let's run the fairness matrix here. So I'm gonna find out the fairness. So what happens here, we are running the binary label dataset matrix to figure out the difference between the unprivileged group and privileged groups. And in this case, if you find out the mean difference between the unprivileged and privileged group, it's negative 0.16, which means it's less. So it's 16% or 70% chance less of if you apply with a person who is under 25, it is less likely for them to actually get this loan. Right. So that's the difference outcome between unprivileged and privileged groups. So that's the difference between. So if the privileged groups apply, which is over 25, they will get the loan, that the people won't get the loan. So let's go ahead and reweigh this bias, which means you see here it's a 17 more positive outcome in the training data set. So that's a difference. If we try to now reweigh means it's an algorithm, of course, which mitigates the bias, which takes the bias away. So I'm going to run this here. Okay, so now running this allows me to mitigate the bias. It doesn't have any output. Just have to run this. All right, so it ran and it mitigated the bias, which means what it did, it took the age feature and took all the rest of the features associated with that and multiplied that with a factor which is going to eliminate the effect age has on the rest of the features. So that's what the mitigation of the bias aspect is. It takes away that thing from here. Okay, so I'm going to go ahead and run this now. All right, and then now the difference between outcome between underprivileged and privileged group is 0. Right, so you can actually look at now the new data set. So this is a transformed data set here. Right, so I can look at this data set, transformed data set. Okay, and try to run it. So I'll go ahead and print. Okay, run this. So you see the transform data set is different than the original data set, because now you see these factors have all changed, because now we have introduced what it was shown earlier, that it actually multiplies that reweighing factor with everything else. So reweighing is one of the algorithms. There's tons of other algorithms out there. It's a huge topic, but I wanted to introduce you to the use case of how AI applies to the aspect of credit scoring using ethical approach. Okay, so that's one view of looking at it. All right, let's move to the. So you saw how we are able to reduce the bias and have ethical AI. Built in there. Now, the last but not least is about machine learning operations. Okay, so I'm gonna reiterate what I started with. Is having three use cases: extracting and understanding healthcare explanation. We saw that how you were able to read from the PDF files. Second was understanding the bias. And the third one now we are going to talk about is how do you apply end-to-end machine learning operations implementations for supply chain. All right, so supply chain, I mentioned what it is, and now we are going to see how we apply machine learning operations. Whenever you are building an AI machine learning system, you have to make sure that all of these components you are seeing on the screen are in place. So you have configuration, data collection, verification, serving infrastructure, monitoring, all of these. So machine learning code you write is a one component in the middle, right? It's you can see that it's not really as big from a size perspective, but it is really important. But there are other components which are really important. For example, if you don't have a serving infrastructure, you can't really consume those libraries, right? So that's why it's super important that you have the capability to actually consume it. Now, let's moving forward. You probably are familiar with the idea of software development lifecycle, right? So you have to have a lifecycle to be able to do software development. So, for example, you have you're gathering requirements, and then you are applying those requirements in user stories. So, depending on if you're using a sprint or using Kanban or other different approaches, you are using waterfall model. In this case, we are going to apply the same logic for machine learning here. So you have CRISP-DM framework is one of the frameworks out there which is used for data mining, as it used to be called, machine learning. It is an iterative framework. You can see the business understanding, the data understanding, the preparation, the modeling, evaluation, and deployment. That's the workflow you will typically see. But now with data science, the data science lifecycle, this is by Microsoft, it's called Team Data Science Process, or TDSP. This is similar to what you saw in the CRISP-DM, but it is more aligned toward machine learning, right? It's more aligned towards how the modern machine learning works. So you have business understanding and the modeling. So it has two different branches. It goes to one goes towards modeling, and the second one goes towards acquisition and data understanding. And then you have transmutation between these two, where the data and the models interact with each other. And modeling part, you can see the feature engineering, training, and evaluation is. And on the right-hand side, you have the data source, the pipeline, the environment, and the wrangling, exploration, and cleaning of the data. So these are both really important part of the things, but it's good to understand the separation of the model from the data, even though at the end, that all comes together, right? So model is essentially your data plus your algorithm. That's what the model really is. So then the model gets deployed, all right? And every time the data changes, you have some sort of frequency set where data changes every week. You're updating the model, making sure it's valid, making sure it's accurate, and then you redeploy it, right? That's the use case. That happens in every environment. Every large company you work for, if they are implementing a solution, they have to have a machine learning life cycle in place. Okay, so what my team and I did, we built this analysis of the problem, this whole entire landscape for a supply chain. Okay, so in this case, you can see that in the data science lifecycle, my team and I, we built this, where you can see the end from the analysis all the way to the deployment of the model, how all of these different components come into play. Right, so the tech stack is this. So you have Helm and GitOps or Jenkins, or you can have any other utility you want to use for operations associated with Git. Git is your source control provider. Then you have Docker container, which contains your entire end-to-end machine learning pipeline, right? So it keeps that. Then you have messaging queue. You can interchange components. These are all open source components. Kubeflow is the main engine behind all of this. It's by Google. It is a machine learning operations pipeline builder, so that helps you do that. Seldom Core, Kubeflow, Pachyderm, and then you're making models using TensorFlow and PyTorch, right? So this is a real world technology stack you can use today to build this model. And you can see several examples on the internet of how it is done. You can download the MLOps. So you can go to Kubeflow's website. You can also look at this ML Flow. That's another one of the tools out there which does something similar. Azure, GCP, AWS, so Windows Azure, Google Cloud Platform, and AWS, all of them have their own machine learning operations platform available as well. So if you want to use, you can use that as well, right? The key message I want to deliver here is for the three use cases is that in each one of these use cases, you would need a data lifecycle, right? This lifecycle and the pipeline. That's what I wanted to talk about in terms of industry use case. It's a cross-industry use case. It applies to all different type of industries. So that's really important part. You should consider how can I utilize that in my industry. So in this case, there was a use case was specifically around supply chain. So they wanted to test out how they can do different variations of different type of products and be able to experiment their models. So every time they change their model, the features they're emphasizing on, how the results are going to be different. So they wanted to test that out. And that's why having a machine learning operations lifecycle or MLOps lifecycle was critical, because you want to make sure that your model works effectively, as in like AUC, ROC, your F1 score, all the matrices you have get tested, the scoring and the performance and the monitoring of your model is in place. And that's why this is a very cross platform thing. So quickly summing it up, we spoke about three different use cases today. There were the case studies we spoke about is extracting and understanding the healthcare explanation of coverage documents from a medical insurance provider. So you saw how we were able to read from PDF files and ask questions from those PDF files and get answers. Understanding bias in model for financial institutions to make correct decision. So how we can find out bias in those models and make them de-biased, okay? And the last one, you saw how you can do end-to-end machine learning operations implementation for supply chain. So this is an implementation of supply chain in that way. All right, I hope you enjoyed this discussion, and hopefully you learned about different use cases around industry as to how you apply this. There's tons of different use cases, tons of different industries, and AI machine learning is on its way to be utilized more and more and not less necessarily, right? So it's getting more and more used in all different walks of life. You saw some of the use cases I showed earlier in the slide here, right? So in different industries, how it is applied. So I hope you enjoy the course, and thank you very much. Assalamu alaikum.